Hello, we're Group 6 and we'll be presenting the manufacturing processes of a wind turbine. Our group members are Jeffrey Palms, Grecia Ortiz, Jose Molina, Alan Molina, Jose Marañón, and Carlos McKinnon. The outline of a presentation would be consistent of an introduction, which would be a brief description of the product, the main parts of the product, the material requirements for such parts, a brief production analysis for each part, and the manufacturing plan for each part as well. And at the very end, how would be the sustainability for such product. A brief introduction of a wind turbine. A wind turbine is a device that converts kinetic energy from wind into electricity. The major components that we decided to talk about the wind turbine would be the blades, the rotor, the tower, the pitch system, the electrical wiring, the gearbox, and the generator. Also, the yaw system.
Part requirements for tower. Designs can be lattice, tubular steel, concrete, or combination. For rotor hub, this is controlled by the blades. Once the blades spin, the rotor spins, which in turn rotates to the shafts that connect to the generator.
Hello, my name is Jose Marañón, and today I will be talking to you about my component, the generator. So what does it do? The generator basically makes electricity using kinetic energy from the wind by spinning a blade. It does this by using a rotating magnetic field within a stationary copper wiring, or vice versa. When the magnet moves around the copper, the electrical field on the electrons is disrupted, causing it to move elsewhere. This is what we know as electricity. The components in a generator include the engine, alternator, voltage regulator, cooling and exhaust system, lubrication system, battery charger, control panel, and the frame. Now let's talk about the gearbox. The gearbox uses gear ratios to maximize the output of kinetic energy to an electrical system using gears. The components in the gear system include the drive shaft, the clutch shaft, the main shaft, the lay shaft, the counter shaft, the gears, the bearings, and the gear shift fork.
Here we have the main shaft, which is used to transfer the kinetic energy from the blades to the generator. The main shaft also must support the torque induced by the rotation of the hub, and it must withstand these forces applied to it. Next we have the bed plate, which is used to house the majority of the parts that are housed in the top portion of the wind turbine. The bed plate is also used to help align parts like the shaft and the generator with each other to prevent vibrations from misaligning parts.
The pitch system consists of several gears and motors. They go inside the rotor hub. They are attached to the blades and they help the blades maintain enough drag and lift force for a wider range of wind speeds. This allows the functionality for the wind turbine to have a wider range of operation. Electrical wiring is a very crucial component of the wind turbine, as is how the electricity gets transported from the turbine all the way to the electrical grid. There are different types of wires that we'll be talking about. Some of them would be for low voltages and high voltages power cables.
Alright, so now let's talk about the yaw system for the wind turbine. So the yaw system for the wind turbine is very important because it is actually used to rotate the wind turbine horizontally so that it can better face the oncoming wind. And the reason that this mechanism is incorporated into the wind turbine is so that the wind turbine can operate at a much higher efficiency, because when the blades are faced into the wind, then it has the ability to harness the full power of the wind and transform that power into electrical energy. Now, the important subcomponents for the wind turbine's yaw system include the yaw drive, the yaw bearing, the yaw brake disc, the brake caliper, the brake pistons, and the gear rings.
So for part requirements, we must talk about both the rotor and the blades. The rotor is controlled by the blades, and once the blades spin, the rotor spin, which leads to the rotation of the shaft that are connected to the generator. The rotor is designed with materials that can withstand the harshest of conditions. Now for the blades. The blades are again what control the rotor. The wind is what moves the blades. When the blades move, they cause the rotor to spin, which leads to the creation of energy due to the generator. The blades are made of materials that can withstand the harshest conditions and are especially made to be very aerodynamic and not affected by drag as much. The way this system works, in general, is by converting kinetic energy to mechanical energy.
So now let's talk about the material requirements for the generator and the gearbox. The generator's material requirements include copper, a magnet of some sorts that can be made out of certain items, insulation, and steel. For the gearbox, we would use something like steel, brass, bronze, cast iron, ductile iron, aluminum, powdered metals, or even plastics.
The materials chosen for the pitch system would be aluminum alloys, carbon fiber reinforced polymers, and thermoplastic. Aluminum and carbon fiber reinforced polymers are good for the pitch system due to their high strength and stiffness to weight ratio. Both of them, they're also very resistant to cyclic loading over time. When talking about the thermoplastic, they were chosen because they have a low coefficient of thermal expansion, which allows them to maintain their shape and dimensions over a wider range of temperature. They also have a good toughness, which is important for components that may be subjected to impact or some other forms of mechanical stress. The materials for the electrical wiring are copper, aluminum, silver, and glass fiber reinforced epoxy. Copper and aluminum would be the most common ones, especially copper. Both of them, they have a good electrical conductivity, and copper in particular has a high corrosion resistance. On the other case, silver is not as common, but it is used when high performance is required, since it has an even higher electrical conductivity. For insulation, we use glass fiber reinforced epoxy. It's a high dielectric material. It has a good mechanical strength and it has a lot of temperature resistance.
The material requirements for a tower can be concrete, lattice, and tubular steel. For rotor hub, can be cast iron and aluminum alloy.
For the material requirements of the main shaft primarily will be made of aluminum and synthetic composites to reinforce the shaft. The bed plate will use medium carbon steel and reinforced fibers to also in turn reinforce the bed plate.
Now, speaking on material requirements, we must talk about fiberglass reinforced polyester and unsaturated polyester resin. Fiberglass reinforced polyester has high strength and elastic modulus, has good corrosion resistance, and has low density. Unsaturated polyester resin has high strength and high elastic modulus as well, is corrosion resistant, has low density, and has very good surface finish.
Alright, so now let's go over the materials for the yaw system. So for the yaw bearing, the material of choice is 52-100 steel, and this is chosen because of its high toughness and its durability. Now for the yaw brake disc, the material of choice is MI00950, and this is a metal-based friction material, and it's chosen because it has a good amount of heat dissipation, so it can withstand a lot of friction and a lot of heating because of friction, and also has a high compressive strength. Now for the yaw brake pistons, the material of choice is EcoBronze, which is an alloy of copper, silicon, iron, tin, and some other materials. And this material is chosen because it's tough, it's wear resistant, and it also has a high compressive strength.
So now let's talk about the product analysis for the generator and the gearbox. The product analysis for the generator is you need a computer, or I would be using a CNC machine, computer numerical controlled machine to cut out the parts, as well as a lathe, a milling machine, and a grinder to make sure all the parts are to their specifications. And for the gearbox, I would also be using a CNC machine, computer numerical control, specifically for the gears, the shaft, and the housing. I would also be using a lathe to make sure that I can get those fine hand precision cuts in there, as well as a milling machine and a grinder.
In regards to production methods, the pitch system consists of several parts such as pitch bearings, pitch motors, and pitch drivers. The primary production method for manufacturing this part is typically machining. There's also some drilling involved as well as tapping. At the very end, they go through surface finishing. This will help resist corrosion as well as make it more physically appealing. In terms of production, electrical wiring goes through several processes. They go through wire drawing, which that involves going through several dies to reduce its diameter. After that, they go to wire stranding, which involves twisting the multiple wires together to create a single strand. Then they go through the jacketing and insulation process.
Building the tower is the first phase. The subsections can be fabricated off-site at the factory, but they are usually assembled on-site. The parts are bolted together and the tower remains in a horizontal position until it is placed. For rotor hub, the design starts with the given blade count and the rational speed. Then the airfoil is selected for each section. That stagger angle is set for an angle attack at the maximum lift to track the radio. The airfoil is scaled for the optimum core length, which is the core length that achieves an axial induction.
For the production analysis of the main shaft, the tools required for manufacturing the main shaft will require a lathe, drilling, grinding discs, and a paint coating, which will be applied to prevent oxidation. For the bed plate, pressure extrusion into a mold will be required. Milling and drilling of the part will also be required.
Speaking on product analysis, we must talk about the rotor and the blades and how they're made. So both of these include casting as their primary process. The secondary process is also the same, which is machining, which involves the use of the lathe, the mill, and the grinder. For the assembly methods, we use the TIG welding, riveting, and bolting for both, since they are attached to each other. And for the surface finish, we use painting, coating, cleaning.
Alright, so for the production analysis, I've decided to focus on the yaw system's yaw brake piston. So for the primary process, it's going to be to draw the eco-bronze material to form the rod shape. The secondary process would be to bore a hole into the rod using a lathe with a boring bar. And then the next step would be to machine the threads for the hole using a lathe. And then the last step would be to machine the external grooves into the piston exterior in order to allow for lubrication. And this would also be done with a lathe.
Now let's talk about the manufacturing plan for the generator and the gearbox. Generator. For the generator itself, I got 5 steps. Step 1, design the generator using 3D modeling software like CAD, AutoCAD, and other kinds of 3D modeling software on your computer. Step 2, you use manufacturing. You manufacture the copper and the magnets as well as the housing using different manufacturing techniques, which include milling, cutting, CNC machining. Next, you finish the components to make sure that everything is perfectly perfect. You gotta make sure that everything measures correctly. Then you do the assembly of the components. The assembly of the components involves careful and precise placing of the components. Finally, you finish the product and you test it in the real world. For the gearbox, the design principles are basically the same thing. For step 1, you design the gearbox. I would also use 3D modeling software, something like AutoCAD, Onshape, SolidWorks. For the step 2, I would manufacture it, but I would use cutting metals. So I would use the milling machine. I would use the CNC machine. I would want to make sure that I can get these gears as precise as possible. I would also manufacture the housing using a mill. Afterwards, I would finish the components to make sure everything is the proper size and diameter and shape that it's supposed to be. And finally, I would assemble everything together to make sure that everything fits perfectly. And finally, I would finish and test the final piece and take it to inspection. I want to make sure that everything's working fine and it's working in order.
This is the manufacturing plan for tower and rotor hub. This shows the tool number, the description, and the symbol.
The manufacturer plan for the PIT system consists of installing its motor to its base bearing, align to the base, install the pitch bearing that will go to the blades, then proceed to install the actuator, the sensors, and the controller that will go inside the nacelle, and the sensors that will go outside of the rotor hub. After that, a final functionality test should be done to assess everything's performing. For the electrical wiring, after wires being produced, it needs to go through jacketing and insulation. Clip the end of the wiring as necessary for the input and output sockets for the different components. Add any adhesive to maintain wires together, and roll the cables for transport. After that, a final inspection is necessary to make sure everything's insulated properly.
For the manufacturing of the main shaft, the first operation will be to design the shaft to withstand torques and to be able to fit the components. The second step will be to manufacturing the main shape on the mill. Third step will be to drill required keys on the shaft and bolt holes. The fourth will be to finish the surface smooth. Then We will paint the outer surface and lastly attach the rotor, hub, and generator to each other. For the bed plate, the first step will be to cut the rough shape using a CNC, 3-axis CNC. The second step will be to mill outer and inner portions. The third step will be to drill bolt holes, then polish the outer surface. Lastly, attach components to the bed plate along with attaching it to the tower.
So for the manufacturing plan, in order to create these, we must first prepare the foundation, then install the base of the rotor onto the tower. Once this is done, we install the rotor hub, install the bearing assembly, then install the blades and pitch to the rotor. Once the pitch is installed, we can now install the pitch actuators to the blade, install the hydraulic system, install the full rotor to the tower, and now we can install the brake system and install the power cables to the rotor, and then install those power cables to the generator.
Now this is the manufacturing plan for the yaw systems brake piston. So the company name is UTRGV Manufacturing Company, and the part name is the yaw brake piston. The first step will be at Unit 601, we draw the rod to required dimensions. Unit 301, bore hole into rod. Unit 202, machine threads into the hole, in the hole. Unit 102, machine the grooves into the piston exterior. Unit 602 will remove burrs from the machine surfaces, and Unit 501 will inspect the part for imperfections and verify the dimensions.
Finally, let's talk about sustainability. For the generator and the gearbox, the generators are the wind turbines are made for sustainability, making its components a lot more difficult for sustainability. Wind turbines are what we use to create green energy, but getting the materials isn't always green. So I believe that a better way to make sustainability for generators is by getting old generators and using them for new ones. For gearboxes, they can be improved by using a lot less actually material when making the gears themselves the same size. You can find out the actual ratios that you would need to make the same size gears with less material.
Sustainability for both pitch system and electric wiring requires to look into several factors. For example, for the pitch system, we use thermoplastic and carbon fiber reinforced polymers because they're low weight, so they have a lower impact in the environment. As well as using higher performance coatings for the components of it will increase its durability and thus creating less waste. For electric wiring, aluminum is a very viable option versus the copper, as it's cheaper and it can go for a longer distance and it's lighter. It is recyclable. And as far as silver and also tungsten, there are another alternate materials that can be used for high performance since they will last longer and thus creating less waste.
Although the product is meant to provide the world with an eco-friendly solution to energy generation, the bed plate and main shafts will require machinery that will release a large amount of waste into the atmosphere. Carbon emissions from the plants add to the health of the surrounding environment. The use of the coating on the main shaft will also add to the release of carbon emissions into the air.
So for sustainability, we must not talk about the materials again. For the rotor, the fiberglass reinforced polyester is very recyclable and lasts much longer than most materials. Using this material for the wind turbine helps us not rely on other materials, and it helps with efficiency, which helps promote the use of renewable energy. Furthermore, it is also cheaper than most materials such as carbon fiber, which also helps lower the manufacturing costs. For a blade, which uses unsaturated polyester resin, this material is also very recyclable and leads to low gas emissions levels. Furthermore, it is cost effective, which also helps manufacturing, keeping the cost at a minimum. In addition, this material is also safe for the environment due to the low toxicity levels and is safe to humans.
So for the sustainability of the yaw brake piston, the reason that this part will be sustainable is because it's made of what's called eco-bronze. So this material is lead free, and lead is a toxic material, so without lead, this material is a lot more environmentally friendly. It's also 100% recyclable, so material from old parts can be reused, and also excess material from machining can be reused. So this increases the efficiency of production and helps to reduce any waste products.